It's wild when you stop and think about the invisible forces all around us. We use electricity literally every second, but it has some seriously mind-bending powers hiding in plain sight. All right, let's get into it.
Okay, so check this out. We're looking at this gigantic crane in a factory, and it's lifting tons, and I mean tons, of solid steel pipe. But look closely. There are no hooks, no claws, no clamps. It's just lifting all that weight with what seems like thin air.
So yeah, that's the big question, right? How can a force we can't even see have that much raw physical power? Well, the answer is in this amazing secret connection between two of the most fundamental forces in nature. To understand what's happening with that giant crane, we're going to have to shrink things way, way down. We're leaving the factory and heading to a simple tabletop experiment that totally changed our world. Okay, so on the left, you've got a basic circuit, but the switch is open, so no electricity is flowing. And the compass needle? It's just doing its thing, pointing north. Simple enough. But now, look at the right. The only thing that's different is that we've closed the switch. The current is flowing, and bam, the compass needle has jumped. It's not pointing north anymore. And that is the key to this whole mystery. It's called the magnetic effect of electric current. Here's the big takeaway. When electricity moves through a wire, it doesn't just stay inside the wire. It creates this invisible magnetic field all around it. That's the force that just kicked that compass needle sideways. And get this, the guy who figured this out, Hans Christian Ørsted, he stumbled on it completely by accident. The story is, back in 1820, he was giving a lecture at a university, and he just happened to have a compass sitting near his electrical gear. He flipped the switch, and he saw the needle twitch, a total fluke, but one that unlocked a huge secret of the universe. And you really can't overstate how huge this was. Before Ørsted, everybody thought electricity and magnetism were two totally separate things. His little accident proved they were actually just two sides of the same coin, a single unified force we now call electromagnetism. This discovery literally rewrote the physics books. So knowing these two forces are connected is one thing. But how do we actually use that? How do we harness it to do something cool? Well, this is where it gets really fun and powerful. And the crazy thing is, you can build one of these yourself. It's like the classic science fair project, right? You just take a regular iron nail, wrap it really tight with some insulated wire, and then you hook up the ends of that wire to a battery. That's it. You've just corralled that invisible magnetic field. And boom, here's what you get. That nail is now an electromagnet. It can pick up paper clips, but here's the magic part. It's only a magnet when the power is on. Disconnect the battery, the magnetic field disappears, and it drops everything. Sound familiar? It's the exact same principle as that giant factory crane, just in the palm of your hand. So what if you want to lift something heavier than paper clips? Well, you can totally control how strong this thing is. You have two main levers to pull. You can either pump more electricity through it, say by using more batteries, or you can just wrap more coils of wire around the nail. More juice or more coils equals more magnetic muscle. But wait, magnetism isn't electricity's only superpower. If you've ever actually done that nail experiment, you might have noticed something else. The wires start to get warm. And that warmth? Well, that's a clue to electricity's other big secret. This is what we call the heating effect of electric current. See, as electricity pushes its way through a wire, it kind of bumps into things. It faces resistance. And you can think of that resistance like friction. All that friction turns some of that electrical energy directly into heat. And once you know about this, you see it everywhere. I mean, the glowing coils in your space heater, your electric stove, that kettle, your iron, your hairdryer, all of these things are designed specifically to use materials with a ton of resistance to turn electricity into heat on purpose. Okay, so we've seen what electricity can do, but in all these experiments, the power came from a battery. So where does a battery get its juice? Well, the answer is pretty weird. It involves a dead frog, a big scientific argument, and some pretty cool chemistry. No, I'm not kidding. It's a true story. It all started when a scientist named Luigi Galvani saw a dissected frog's leg twitch when he touched it with two different types of metal. He thought the electricity was coming from the frog itself, some kind of animal electricity. But another scientist, Alessandro Volta, he had a different idea. He thought the power was coming from the metals reacting with the frog's, well, moisture. And guess what? Volta was right. His insight led him to invent the very first true battery, which we call the voltaic cell. And the principle's actually pretty simple. You take two different metals, those are your electrodes, and you stick them in some kind of liquid solution. That's your electrolyte. The chemical reaction between those two things is what gets the electricity flowing. And you can build a version of this in your kitchen. Just grab a lemon, stick a piece of copper and an iron nail in it, and that's it. The copper and iron are your two different metals, and the acidic lemon juice is the electrolyte. Now, it won't power your TV, but if you string a few lemons together, you can actually light up a tiny little LED. Of course, today, we've taken that basic idea and perfected it. We mostly have two main types of batteries. You've got your dry cells, those are your typical, everyday disposable batteries. And then you have rechargeable batteries, which are the workhorses in our phones, laptops, and electric cars. So after over 200 years of battery tech that started with a frog's leg, what's next? Where do we go from here? Well, scientists are working on the next giant leap forward, and it could change everything. It's something called a solid-state battery. The whole game-changing idea here is to get rid of that liquid or pasty electrolyte, the lemon juice part of the battery, and replace it with a special solid material. It sounds like a small change, but it could solve a lot of the biggest problems we have with batteries today. So what does that actually mean for us? Well, for one, they'd be much, much safer because there's no flammable liquid sloshing around inside. They could also charge way faster. We're talking minutes instead of hours. And they could hold that charge for a lot longer, giving our gadgets and electric cars a much longer life. So think about that. We started with a giant crane lifting steel, and we ended with the future of energy in our pockets. The whole journey from a twitching compass needle to a frog's leg was driven by pure curiosity and happy accidents. So it kind of leaves you with one big question, right? What tiny accidental discovery happening today is going to be the thing that powers our entire world tomorrow?